guys, today our topic is the most important topic for BSc and MSc students. So optical isomerism, simple tricks. You have to find out molecule is optical isomerism or not. So full explanation మన ఛానల్లో ఉంది, and after the explanation I will put the notes for semester exams. టోటల్ థియరీ ఉంటుంది. సో చెక్ చేసుకోండి అండ్ సబ్స్క్రైబ్ చేసుకోండి. ఫస్ట్ ఆఫ్ ఆల్ మీకు వీడియోస్ అన్నీ కనిపిస్తూ ఉంటాయి. సో ఏమైనా డౌట్స్ ఉంటే కనుక కమెంట్ చేయండి. సో ఫస్ట్ ఆఫ్ ఆల్ వాట్ ఈస్ ద ఆప్టికల్ ఐసోమరిజం? సో కమింగ్ టు డెఫినేషన్. So in this diagram, this is the plane polarized light. Okay, you have to take one plane polarized light, and this is passed to the prism. From prism to light is passing through the solution compound. You have to take one solution compound. That means this is the coordination complex. When light is passed through the prism, this light is passing through the solution compound. That means coordination complex. When the light is passed through coordination complex, then it will be divided two types. That means one is right and one is left. So again, simple definition, guys. So again you have to take plane polarized light, and this will be take the prism, and light is passed to the solution compound. Then the rotation is like this. That means there is no rotation. So now coming to example, when light is passed through the plane polarized system, plane polarized light when passes through the solution compound, then rotate the plane polarized light is set to optical active. That means rotate. When the light is passed through the solution compounds, then it will be rotate. Rotate means that is right or left. One is right, one is left. This is rotation happen. So this is optical active. And another is when light is passed through the prism, coming to solution compound, that light that rotation is not happen. That means there is no rotation. That means this is optical inactive. Simple definition, guys. When the light when the plane polarized light passes through the prism, this passes through the solution compound, that means coordination complex. When the rotation is happen, that is optically active. When the rotation is not happen, that is optically inactive. When the rotation is happen, that means right and left. When the right side is happen, that is D. When the right side rotation, that means you have to call it as D, dextro. And the left side rotation we have called as Leo. That means Leo. Right side is D and left side is L. So this is the optical isomerism definition. So when it comes to square planar complexes, so coming to explain that square planar complexes. In optical isomerism, you have to find out. In square planar complexes, optical isomerism, how to find. So what is the square planar complex? Here you have to consider planar, that means ఈ నేమ్లోనే ఉంది, that means planar. This గుర్తుపెట్టుకోండి, planar. So planarity, that means you have to take the structure of square planar, that means like this. This is the structure of square planar structure. In this structure, ligands and metal has same plane. That means ligands is A, and metal is. That means ligands and metal are same plane. So planar symmetry, plane of symmetry is present. So what is plane of symmetry? So definition of plane of symmetry: it is an imaginary line passes through the molecule. It we get two equal halves. That molecule is plane of symmetry. When the plane is passing through the molecule, this is when the line is passing through the molecule, then it will get a two equal halves. That means that is the plane of symmetry. In this square planar complexes, plane of symmetry is present. That means when you cut these two halves, here AA and AA, metal is half. When it comes to half, this side AA, metal is half. So in this two equal halves, that molecule has plane of symmetry. When the plane of symmetry is present, that is optical inactive. When the plane of symmetry is not present, that is optical active. So when the plane of symmetry is present, that is optically inactive. When plane of symmetry is not present, that is optically active. Coming to square planar complexes, in these square planar complexes, plane of symmetry is present. When plane of symmetry is present, optically inactive. So optically inactive means there is no optical isomerism. So if any molecule is present optically inactive, that means no optical isomerism. When is optical active, that is show the optical isomerism. So coming to square planar, there is plane of symmetry is present in square planar complexes. That means optically inactive. In this optically inactive, there is no optical isomerism. So this is square planar complexes. So coming to tetrahedral complexes. Sorry guys, square planar complex. All the square planar complexes are optically inactive. That means no optical isomerism. Only one molecule. That means only one molecule. Palladium EDTA -2. This only optically active. This complex only show the optical isomerism in square planar complexes. Coming to tetrahedral complexes. So what is the tetrahedral complexes? In this tetrahedral complexes having a chiral center that show the optical isomerism. In this tetrahedral complexes, when the chiral center is present, that can be show the optical isomerism. So coming to chiral center. So what is chiral center? Chiral center means central metal has 4 different groups that are non-superimposable. That means central metal atom has 4 different groups that non-superimposable. That means this is the chiral center. So for example, you have to take one example. When chiral center is present, that is optical isomerism. Coming to tetrahedral complexes, only M, A, B, C, D complexes can show the optical isomerism. So only MA, B, C, D complexes only show the optical isomerism. No other complexes cannot show the optical isomerism. That means there is no chiral center in that complexes. So what is chiral center? Coming to MA, CBD complexes. For example, you have to take like this: M, A. So this is B, this is C, this is D. You have to take the structure like this. So when you rotate, that means super mirror images. That means how to write this B like this D, it will be rotated. That means the superimposable or mirror images. You have to write like mirror images. That means B is like, D is like, and C is as usual. So this is the mirror images. When you put this structure to this here, mirror images, that means here B, here D, here B, here D. So that means mirror images. And there is no um, mirror here mirror images, and there is no optical inactive. That means this is optical active. This show the chiral center. That metal is have the chiral center. That means different groups in this metal atom, and here also the different groups in metal atoms and mirror images. So superimposable. So this is the optically active. So this show the only tetrahedral complexes. These complexes, that means M, A, B, C, D complexes can show the optical isomerism. This is the example for this, and this is D and this is L, dextro and leo. So this is the example for tetrahedral complexes. So డిస్క్రిప్షన్లో లింక్ ఇచ్చాను ఆక్టాహైడ్రల్ కాంప్లెక్సెస్ ఫుల్ వీడియో ఒకసారి చెక్ చేసుకోండి. అండ్ సబ్స్క్రైబ్ చేసుకుంటే కనుక మీకు వీడియోస్ అనేది కనిపిస్తూ ఉంటాయి. అండ్ ఐ విల్ పుట్ ద నోట్స్ వన్స్ చెక్ చేసుకోండి ఫర్ సెమిస్టర్ స్టూడెంట్స్. దెన్ యూ కెన్ చెక్ ద నోట్స్. సో దిస్ ఈస్ ద ఆప్టికల్ ఐసోమరిజం డెఫినేషన్ and total theory part for semester students. Once you can check it. So if you have any doubts, కమెంట్ చేయండి. అండ్ మెయిన్గా సబ్స్క్రైబ్ చేసుకోండి, మీకు వీడియోస్ అనేది కనిపిస్తూ ఉంటాయి. సో దిస్ ఇస్ ద plane of symmetry. This is the square planar complexes, and this is the octahedral complex, tetrahedral complexes. For octahedral complexes డిస్క్రిప్షన్లో లింక్ ఇచ్చాను. దెన్ ఒకసారి చెక్ చేసుకోండి, మీకు వీడియోస్ అనేది కనిపిస్తూ ఉంటాయి. థ్యాంక్ యూ గైస్.